Okay, so we're going to look at patterns and sequences and everything that goes with that. So to start us off, we're just going to do a bit of an intro. So looking at kind of what is a pattern generally. So with this, I suppose you can kind of follow along with your own notes. We're kind of working through the sections in the notes, but I'm just going to do it with these ones here just to have a few extra examples, kind of extra to what we have maybe in the notes. So looking at a pattern generally, so a pattern like this, a number pattern, so 4, 8, 16, 32. And what's the next number? So to get the next number, we kind of look at what's the pattern, what's happening between each of the numbers. So here we're going plus 4, here we're going plus 8, here plus 16. So really what's happening is each time we're doubling. So we'll start with 4, then we get 8, then we get 16, then we get 32, so we get 64 then coming next. Okay, and after 64, double that again, 128. To do the next one, so 4, 7, 10, 13, 16, again, we can look at what's happening between each of these numbers. So to go from 4 to 7, we need to add 3. To go from 7 to 10, we add 3. To go from 10 to 13, we add 3. So we can kind of see the pattern here is that I'm adding 3 each time. So to get the next two terms, I add on 3. So my next term is 19. I add on 3 again. My next term is 22. Okay? So in a sequence, each number is called a term. Okay, so a term. So in our pattern, the first number in the pattern is called the first term. So for the ones that we've looked at there, for both examples, the first term would be 4. The second term in the first one would be 8. In the second one would be 7. So this is the second term. The third term then obviously is just the third number in the pattern. What's important here is how we kind of use that language. So you can see here T1 is the first term. So the T stands for term and the small number stands for the number of the term, or what we call the term number. Okay, so this number here, small number, is called the term number. It just tells us which number, which term is it? What number of term is it? So is it the first term? Is it the fourth term? Is it the seventh term? Or so on and so forth. The actual number, so for example, when we said T1 the first term, and that was 4 in our examples there, the actual value is the term itself. So the first term is 4, but the term number is 1. So it's term number 1, and the value of that is 4. Yeah, it's really important that you kind of know that subtle difference between the two there. So the term number is the small number down here, and that tells us what term we're looking at. The first term, the fourth term, the third term. Think of those numbers, first, second, and third, those kind of values. And then the actual value of that, so T1, is the number in the pattern. So that is the value of 4. Or like T4, the fourth term, if I look at my pattern, that would be 13. So T4 would be 13. Okay, so it's important to just know the difference between when are we looking at the small numbers and when are we looking at the actual value. So sometimes we want to work out the pattern so we find the difference between the terms. So that's kind of what we did in the first one. So here, looking at the difference between them, we go up in 3. To get from 6 to 11, we have to add on 5. To get from 11 to 17, or to 18, we add on 7. To get from 18 to 27, we add on 9. And to get from 27 to 31, we add on 11. So we can see here we're going up in kind of not the same amount each time. If we maybe look at how we're going up in those, we can actually see that what's happening is each time we're going up by 2 more than we went up the previous time. So we can see it's not always that we're going up in the same amount, but there might still be some sort of pattern. We were going up 3, 5, 7, 9. You'll notice they're all kind of your odd numbers. So we're going up in a different odd number each time. What this all leads on to then is this idea of looking for what we call the nth term. Okay, so thinking back to what we were saying earlier, and we were talking about those small little numbers that were beside the t. Okay, so we were talking about the first term, the second, the fourth term. The nth term is giving us a general rule for a particular term in the sequence. So if I'm looking for Tn, I'm looking for term number n, the nth term in my sequence. So that will have a value, that will have a number value. But what we can do with this nth term is we can use it to find a specific term. If we want to find a certain term, such as here with the 100th term, we can find that term without having to work out all the terms that come before it. So looking at, I suppose, like we had here, we can work out the difference, we can add that on, we can continue working out the pattern, but using this rule now, this Tn, we'll be able to find any pattern or any number in the sequence without having to work out the previous ones. We can kind of see how that works a bit here. We're told that the nth term of a sequence is 4n minus 3, and what that means is for any number in this sequence, if I want to find the value of term number 1 or term number 2 or whatever it is, I can just sub that in for n, and that will tell me what the value is at that point. So to see how that looks, if we have t1, okay, comparing it to what we said there about tn, we can see that 1 is where we would normally have n. So if we follow it through, 4 times 1 minus 3 gives me 4 minus 3, it gives me a value of 1. So what that means is that the first number in my term, or the first number in my sequence, is going to be 1. If I try t2 then and get my second term, again I just sub in 2 anywhere that I see n, that gives me 8 minus 3, which gives me 5. So the second term in my sequence is 5. You should be able to see here that each time we're subbing in for n, because n is the term number. If I want to get term number 3, and the value of term number 3 is 9. Same thing with term number 4. Again, I just sub in for n anywhere here. 16 minus 3, and I get 13. So term number 4 is 13. Okay, and we follow through that way. If we find the fifth term, I suppose, just to continue it on. 20 minus 3, I get a value of 17. Term number 5 is 17. Okay, so we can see what's happening there. So each time the value of n is whichever number of term I'm looking for. So first, second, third, fourth, those ones, all think of all those words with the little letters. You know, you're looking for an order. The actual value then is the number in the pattern. Okay, we also will see where this comes up in relation to shapes. So applying a pattern to shapes as well. So we can see that we have an example here. And one of the best ways to see how a pattern is happening to a shape is to start from what we're given in the first design and try and plot that onto the next design. So you can kind of see I've kind of drawn that out here. So starting with the first design that we have here, just the one circle on its own, if we take this red circle then in the next part to be that original circle, we can see what's happened for the second design is we've added on 2 more to the end. If we then take that as our green part here and map it onto the next part, we can see again what happens is I add a circle onto each end, and we can see that's what keeps happening each time. If we fill out our table, there's 1 dot in the first one, there's 3 in the second, there is 5 in the third, there is how many in the fourth? 7, and there is 9 in the fifth. So what's happening each time? Well, if we look between them, we see that each time I'm going up in 2, which makes sense. I'm adding 2 dots on to my previous design. How many counters are in the 6th design? Well, we could add it onto our table here. So 6 designs, add on 2 more, and we get an answer of 11. How many counters do I need to make the 15th design? So remember again, 15th design, 15 is going to be that answer for n. So I'm looking for t15, and I want to know what the value of that is. So I'm adding 2 on each time to the previous designs. So to get the second design, I added on to the first one. To get the third design, I added on 2 twice. To get the fourth time, I added on 2 3 times. So each time I'm kind of adding on 1 less 2's, I suppose. So to get the 15th design, I need to add on 1 plus 14 2's. Okay, so 1 plus 28, which gives me an answer of 29. Okay, so the number of 2's that I'm adding on is just 1 less than whichever term number I'm looking for. I'm kind of relating them back to the previous term. Which design uses 99 counters? Okay, which design uses 99 counters? So, interesting one. This time we are looking for instead of having n, we are looking for when is Tn equal to 99. Okay, when is Tn going to be equal to 99? And this sort of question is one that we will be looking at as we go further as well, when we get into kind of coming up with the formula for Tn. At this point here, we're maybe making a bit more of just a guess, making a bit more of an estimation at the question. We've kind of seen there that I'm adding on a certain number of 2's each time. The number of 2's that I add on is kind of less than one less than how many that is one less than whichever term that I'm looking for. We've kind of said that it's 1 plus, maybe I'm looking for n, it's n minus 1 2's that I'm adding on each time. That's going to be equal to 99. I wouldn't be all that worried about this part here because it's something that we're going to look at in the next little section, okay? But looking at it, I suppose 98 divided by 2 is going to give me an answer of 9, and we get that n is equal to 50. Okay, but this is something that we're going to look at in the next section, is how do we come up with this value for Tn? So rather than, as we've done here, maybe just kind of estimating and making a guess and just kind of working it out kind of more generally, we want to see how do we kind of make this more methodical? How do we really make a real kind of definite way of coming up with Tn? So that's what we're going to look at in the next section.